Yeah, so we were discussing about the topic of cost estimation. We had some of the theoretical discussions about how do you go about like just starting to estimate the cost in a particular infrastructure project or particularly for construction project. And all I was explaining to you was the structure, the direct cost, the indirect cost. Indirect cost, there is a labor cost involved, there is a human, the material cost is involved, and then there is a plant and equipment related thing that we have to generally consider. And then there are indirect costs which you cannot attribute to any specific activity. So you take kind of an average and divide them among the total volume of the construction that you are going to do and so on and so forth. So we'll see that. And the basic idea, what it requires, the information that you have to have in order to estimate these costs is immense, right? We saw that you need to have so many factors built in even a single value estimation. And that is the complexity of this whole problem, that in real world it is not as easy as it seems. So far we have been given the cash flow series, but estimating cash flow requires tremendous effort in real world, and that's something I just wanted you to appreciate. And then we went on to start this concept of unit rate estimating. The idea being that once you know the unit rate of a particular activity and you know the total amount of that activity that you have to do, the total cost will be multiplication of the unit rate multiplied by the quantity and then taking sum of all such minor things, right? Now the challenge that you have here is there is no fixed definition of what a unit is. It depends on activity. For example, for concreting work, we saw the unit as cubic meters of concreting work, or I will actually help you also estimate that. Just for material, cement bags, we calculated in terms of kgs. For the steel, we calculated in terms of again tons or kgs, right? Earthwork, you will measure perhaps in cubic meter. If you are to do work on plastering, you will measure in terms of meter square. So there is no one standard unit. The unit keeps on changing depending upon your activity, but that's how it is, right? And the two concept that I introduced, one was this unit rate estimating, and then second was the operational estimating. And the only difference between the two is in operational estimate you have some sort of an assessment of productivity, how much of unit per hour or how much of unit per unit time a particular piece of machinery can produce, and that factor is accounted for in that. But these two methods, as we discussed, that these are not really independent of each other. In any cost estimation, you will be using them parallelly and almost interchangeably. Like you won't even recognize when you are shifting from one to another. That's the kind of thing. So in that, I gave you examples of, for example, 1 metric ton of cement. Material will involve not only the cost of just the raw material, also the transportation, handling, and things like that. Some wastages. Similarly, for the labor cost we estimated, we divided it into the skilled, unskilled, and semi-skilled. We also took their overwork and some sort of some charges in terms of overtime that they do, some profits, normal minor tools that you need to provide to them. And assuming that there is a ratio between skilled, unskilled, and semi-skilled for a particular activity, then you can estimate on an average per hour how much do you need to pay for labor charges, right? So that's where we actually left. Now using these, I just wanted to show you how some of the other things you can do, and we'll just go through one comprehensive example today, right? So here you see derive the rate from a contractor's perspective for 1 cubic meter of excavation of earth in normal soil, where the depth of excavation varies from 0 to zero point 0.5 meters. So this is a open excavation, or in a trench excavation where the depth of excavation varies from 0 to 1.5 meter. So excavation, what is the main cost do you expect? Manpower or machinery. It could be machinery, it could be a manpower based job. What else? Conveyance charge of for what? So the material that is coming out of earth, you need to displace it because you can't keep just storing sideways. So that requires some time. What else? Or some cost. What else? Do you know what's the difference between open excavation and trench excavation? Open excavation is slightly less deep, and the ratio of this perhaps these two, whatever this A by D ratio, this is not too slender essentially. So there is not risk of soil caving or there is slightly less risk of soil cave-in. So in that case, you don't need to worry about preparation of the soil, or you don't need to worry about putting some sort of a formwork to make the soil stable, because you expect that this is not going to cave in. What happens is, in excavation, the soil which you have excavated, because of the pressure, the overburden pressure that you might have heard from the surrounding soil, this kind of caving, and that's a safety hazard. That's also your work will be not effective, because then you don't have, because the material is going inside again. So the trench soil or trench based excavation usually requires some sort of a profile. It's a little bit more complex profile than a normal excavation. Now you may need to put some sort of a soil stabilization material. Either you put a slurry or something, or you might even put some sort of a foam work here to make, or some sort of anchor bolts and things like that to keep the soil from caving. Right? So this is slightly more complicated. Again, I'm not including all these things in the cost, but you have to have this idea. For going about any activity, you should understand the engineering process behind it first, and then try to accommodate all those factors in your unit rate. Right? That's the main principle. Right? So for open excavation, we are assuming that no such treatment is required. It's only a manpower based job. It could be also a machine based job, but in this case, we are assuming it's a completely manpower based job. So essentially what you need on per cubic meter, how much man hour is required. If you can estimate that, you have already estimated the labor cost in terms of the per man hour. So all you need to do is multiply by the per man hour cost, multiply by how much a man, or basically a labor, can excavate, how much quantity they can execute in 1 unit of their working hour. Right? All is that what you need to estimate. So this kind of an estimate you can typically find from your finance team, because they have been collecting this data from past issues. On an average, they will be able to give you that understanding that, okay, per cubic meter you need 2.16 man hours, and that 1 man hour cost you have already estimated 109 rupees in the previous example. So your total cost comes out to be 235 rupees per cubic meter. Right? Got an idea? On the other hand, if you had to do the trench excavation, this is the some sort of a generic profile. It could also be some sort of a profile like this, as I told you earlier. That is also a possibility. So again, you will have to see what kind of rock conditions, bed conditions are there and all. But in that case, it's not only a labor work, and of course labor will be higher, because now you are going deeper. You are going instead of 0.5 meter, you are going to 1.5 meter. So same cubic meter of earthwork will require more effort. Why? Because perhaps you need to transfer the soil from much depth compared to the earlier case, and that extra steps is reflected into the number of man hours required. Instead of 2.16, we're talking about 3 man hours on an average. But you also need sloping and work space, which I've given you estimate in this case is just a 15% of the total amount. You may need dewatering and shoring. Dewatering is essentially you need to sometimes the water gets filled, or you need to suck the water out from this particular area, because water is the one that creates the overburden pressure, and that actually can help or maybe lead to cave in. So there is some cost associated with that also. Right? Again, we are assuming that all these values are given to you here. That's where the real challenge is, but I'm just giving you some idea around that. So you will see on an average your trench excavation is, compared to 240 here, it's about 380 per cubic meter. Right? Let's look at a more comprehensive example of combining both the information, the productivity norms as well as the material norms, on how do you really go about it. So total concrete quantity to be poured in a project is specified as, this is I think 1 lakh cubic meter or 10,000 cubic, 1 lakh cubic meter or M15 grade, and it has to be completed in 16-month duration, although the total project duration is 20 months. Right? Very realistic. 16 months you have to totally pour about what? 1 lakh cubic meter of the concrete. The contractor needs to estimate the cost of 1 cubic meter of M15 grade concrete. So in general, in concrete, M15 grade concrete, what all components will be there? Can you start listing? Sand. Such precise. Yeah, so I'll start with material. In material, What all materials are there? Cement, aggregates, sands and whatever, aggregate, coarse and fine, and water and admixture. And so this is just, I'm asking concrete, and when I specify concrete, is it what? It's a structural concrete, there is a reinforcement or not? Equipment, what kind of equipment? Straight away, vibrators is the first thing for concrete. What else? Shuttering. Shuttering is what? That's foam work. We will keep it separately. What else? Concrete pumps, mixers, transportation. That depends upon whether you are using a ready mix concrete plant or not. But at the same time, even if it is an RMC plant, at the site, local transportation has to take care of, right? What else? Workmen for what? Workmen for material shifting and concreting and formwork placing and curing. What else? Supervisors and all. Okay. What else? Tools and consumables. And what else? So all of this will go into this and you can get an idea. This is just about the cubic meter of concrete, and concreting is not the only process in a construction site. So you can get how complicated things really become, and we'll just solve for cubic meter of concrete right now, but similar things then need to be done for everything. So this estimating job is it's only multiplication, most of the time addition and multiplication, but you have to be extremely careful because there are lots of chances of making mistakes there, right? Alright, so I had written so much things already, still you were giving me so less answers. Okay, so the total cost of concreting would be sum of the materials, the labor cost, the plant and equipment cost, and the overhead whatever is there. And we are not calculating overhead costs from this problem because it's whatever, but essentially this will be distributed on a pro rata basis of how much is the total company's overhead distributed about the quantity of the work and things like that you can do, right? But let me give you an example. So let's first estimate how much is the concreting requirement, right? Right now you have a cubic meter and you have been given that you have to pour this much concrete in 16 months. So you need to have some sort of an estimation of hourly requirement of concrete, because depending upon that, that will govern the size of the plant or the size of the machinery that you need, right? There could be that you just need some 20 cubic meters per hour versus you may need 40 cubic meters per hour. Depending upon these two, it may affect the number of equipment that you need, because equipment also have their own capacity and their hourly output rates. So that's a prime estimation. So the first is total duration of the project is 20 months. Concreting duration out of that is 16 months. Concreting per day would be what? Assuming that in a month 26 working days will be there, so you are assuming about 240 cubic meter of concrete per day. Peak concrete, because you are not expecting a uniform concreting rate every time, you may have a rate which is like, right, because you will not start all the concreting in the uniformly. So peak concrete could be assumed as this 1.5 times the average value. Again, these are all rough numbers. You could argue, again, you could also estimate based on the actual schedule. You know the concreting activity. In this case, I am just assuming that's 1.5 cubic meter. So that's about 360 cubic meters in a day. Now, assuming the number of hours in a day is 8. So you are dealing with the capacity of 45 cubic meters per hour. Right? That's the kind of, this gives you an idea of what is corresponding number of labors that you need, what is the corresponding number of equipment you need, what is the number of plants you need, and all those things, right? So here I have given you the list of equipment that you will require in order to serve this demand of 45 cubic meters per hour. Again, this is where your civil engineering judgment will also come into the picture. You will need to know what kind of machinery is available nearby this particular project, what are their hourly output rates, how much they could serve, and accordingly estimate how many number of each of these equipment you will actually require, right? How many of you know batching plant? Do you know what batching plant is? So essentially it's the concrete making, part of the concrete making process, where in large silos you store all the individual materials, that all comes, starts getting mixed and starts getting output as a transported, right? Wheel loaders, do you know what wheel loaders are? Wheel loader is basically a machinery. I think JCB is the brand name, but essentially it has a kind of a trolley in front where it can pick a large quantity of material and deposit from one place to another, right? Just search for it. Transit mixers are the mixers you need to keep the concrete agitated so that it does not settle in while you are shifting it locally on the site, or in case the RMC plant, then you need to have that rotating trucks, right? Mixer machines, again, similar kind of a thing. Tough riders, essentially it is a small vehicle which is used to transport, not like a truck, but small vehicle which is used to transport the concrete. High lift pump, you may require the pumping because your pumping could be horizontal as well as vertical, because if you're dealing with a large construction site spread over large areas, you might want to pump to near a station and then take the concrete from there. Or if you're working at heights, you will still need to pump the concrete to reach at height. Curing pump, because concrete placement, after that it will also require curing. You need to put water in it, you need to not excess water, not so less water and things. Boom placer, this is essentially in a pump with also the placement possibility. So this is like you bring the concrete into a boom placer, then you can extend its arm, which has a pipe going through, and so that you can actually directly place the concrete at where location where you want to, and then you can rotate the boom placer. It has some good degrees of freedom. So from one location you can cater to large area for this whole thing, right? Weighing batches, vibrators, builders hoist, tower crane, all these things you can estimate, right? Just if this was not complicated enough, in each of this we also need to worry about so many plant and equipment, right? And here I am giving you all these numbers, but you also need to estimate these numbers in real site. This will not be by default given. Yeah, most of the time, good engineers with practical experience, day-to-day life, they are dealing with this. They will be easily able to tell you all these numbers, but it seems overwhelming when you are just in the class, not aware of the realities. But yeah, these are pretty standard numbers that they actually use on a day-to-day basis. So corresponding to this, you will have a only either renting or purchasing kind of a cost associated with these equipments, right? So I'm assuming that all of these equipment and machinery is hired, it's rented, not actually owned. So you have all the numbers, you have the total number of months you need to have them for lease them. I'm assuming originally was 16. I'm assuming 1 month of a cushion because your project might get delayed and all. So you may want to have a agreement that this will be required for 1 additional month just in case. Otherwise, they'll ask you to return all the material, all the equipment, and maybe your concreting work is not done. So just to add that cushion, you have this for 17 months. Essentially, you get number per month hiring rate, number of months, you get the values that you are going to have for total, right? This is just to lease the equipment. In that, there is some maintenance, you need to create some temporary structures to host these all sorts of equipment, some sort of a tower crane foundation, because the tower crane requires that assembly, otherwise it will not be stable. You may need to do ground improvement for some of these heavy machinery to be used, and so on and so forth. Assembling and dismantling process, not a lot of these equipment do not come ready to go. You need to assemble them on site and then dismantle once your work is done. Mobilization, whatever, so you need to pay to bring the site, all these equipment on the site, you may need to pay for all this, and therefore the total cost comes out to be some big number like this. Okay, this is what we estimated, hourly cubic meter requirement. Using that, how many number of equipments we need and the time that we need to own this equipment, and essentially that's what we have done. But machines require fuel. This is just owning the machines. Fuel is separate. So for fuel, and also you need sometimes the oil and lubrications, because you need to keep the machine running in a good condition. So all those calculations are here. Your individual number of months you require in each month, how many days, on a single day, how much number of hours you are using it. This F by P factor is essentially the productivity kind of a norm, in a way that for this machine to produce 1 unit of power, which it is doing, how much quantity of fuel you need to get out of it, or how much fuel it will require, right? So that kind of an F by B number. So essentially, and then the total cost, this is the cost of the fuel that goes into these machinery. I don't know why this fuel is of different variety, and that too so much different. I'll have to check these numbers, but essentially you get the idea. And then you may multiply some sort of an extra margin of oil and lubricants that might be required to keep the machines running in a good condition. So in that, some of the machines which are more heavily equipped or they have more moving parts, you will have larger factor to multiply. Otherwise, you may just not worry about this particular thing at all. And then you start multiplying all this. 2 into 16 into 26 into 8 into 64 into 6 should be this number. Okay. Similarly, you keep on adding. So this is this much money you will require just for fuel and power and oil and lubrication of operating these equipments. All right. But it also requires human. Machinery requires human. So that is where you need to have how much skills, how much skilled workers, or what kind of crew is required to support each of these equipment, right? So that's where your numbers are there. Months, 26 days, and in a day, since we are assuming 8 hours already, that's by default our assumption, and that's where we also estimated the hourly wage of the workers in the previous examples I showed you, right? 610 was for per day, assuming a day was 8 hours long. So we are using that number directly. So you get all this amount of just the labor, how much labor you will require to operate this machinery, right? In that, there would be some overtime again you are using. There's lot of overestimations involved in these things, because there's a lot of uncertainty around it. It's not that it's you are unnecessarily giving 50% extra. It's just because there's so much uncertainty, actually end up spending much more. So you typically do it on a conservative side rather than being a too optimistic side of your estimations, right? So you get the amount that is required, or the labor that you will spend only for operating the machinery. Got it? So far, equipment, number of equipment, leasing, oil and power, and people to operate that machinery. This is what we have done. But this is not the full picture. Labor is also required for actual concreting activity. This is just the machinery and machinery operation. But you need people to actually do the concreting work. That is, you need masons, you need carpenters, fitters. What is mate? I have to check. Helpers and all. I have to check exactly what exactly this is. I have taken this example from Professor K.N. Jha's book. He is a professor in IIT Delhi. So that book has a more detailed example. If you want to, you can. I think you read it in your project management class anyhow. So again, daily wages, number of hours, number of months, number of people, you multiply and you get the total cost. Concrete curing. Not an easy task. Most of the time, manually intensive. Right, you need to ask people to keep the concrete in a good watery condition wherever, or sprinkle the water over it, or sometimes you have some sort of a gunny bags applied to it, so you need to keep them watered, maintain. Otherwise, without curing, concrete does not work. So that is where you need to have all this more number of people, pump operators, coolies, Sunday wages if it is. Yeah, curing cannot stop on Sunday. So that's also there. So 26 days is not there. They have to work on some time extra. Operators, some coolies, total for curing labor, you can have more numbers included in this. Okay. So this is just the summary of plant and equipment and associated labor cost for concreting work. So your owning cost of plant and machinery was this. I'm just consolidating all the numbers from previous tables. Fuel and power cost, operating labor, concrete placing labor, concrete curing labor, miscellaneous, the total per cubic meter is so much money, 1851 rupees per cubic meter for 1 lakh cubic meter of estimations. This could change drastically. If you go from 1 lakh to 2 lakh, the requirements may not linearly increase, they may increase non-linearly. So you have to do the calculations again. This is assuming 1 lakh. That's a essential understanding in the entire calculation. So this total unit is part of, you need to be clearly defining that according to this we have calculated. All right. Then material cost, this is just the plant, equipment and labor. Now actually the material cost. Cement bags, sand, aggregate. Assuming that you know the M15 grades, whatever the mixed design is. Accordingly, this comes out to be some 3,543. In that, again, each bag will also have the transportation cost involved, all the small minor material handling and all those things are inbuilt. We have already seen those examples. Here I am giving you just the numbers directly to multiply. Okay, but each of these can go into so much detail. So your total concrete per M15 grade, assuming that it is a non-structural, so there is no steel as such, but essentially this is 1851, which is the plant and equipment, material cost, which is 3,543, some miscellaneous labor based on some existing rate on top of. So each table you see there is a lot of margin inbuilt, and that is necessary also. It's not always for a waste. So total is coming out to be 5,419 rupees per cubic meter. Okay. So this is how you see, in that we combine both. We combine the unit rate. We also combine the hourly productivity information. We converted units to a time requirement and then converted back using some sort of a multiplication. So that's how you, in real, you will never be able to distinguish which method you are actually using. They go parallel, hand in hand. Either you are doing only just adding up the quantity directly, or you are multiplying some sort of a productivity norms and hourly rates and all those come into the picture. And that is how the calculation is done. Easy to follow. Lot of assumptions are there. This is also comes from the site requirements and all. So even I will not be able to explain you in detail, but you just have to understand that this is how the process has to be done. Okay. Now, corresponding to this, there is also a stock or temporary structure that you can actually do. So stock is essentially your typically stock is treated as whatever material you need to store at site, but stock is, in financing terms or the accounting terms, stock is of assets, and assets are not only materials but many other things are also part of the assets of the company or a project, right? So this site office, because this your typically site offices are like temporary structure which can be moved from one place to another. Like you will see those tin containers fitted with AC and all. That is not dismantled after the site. It just goes to something else. So it's owned by the company. It's an asset of the company. So all this comes as part of the stock calculation. So stocks are the site office, actual material stores, client office, architect office, some sort of a maintenance workshop for minor maintenance in the machinery. And again, this maintenance workshop, all these machine will go away. Quality control laboratory that you set up. Quality control laboratory is not only for that site. Once you're done, you will shift it to some other site, right? So all these things are there. So I'm also giving you the quantities of that. This is roughly in meter square, which is the surface area or the total area that it requires. That's the kind of working unit that goes, and you can also estimate some of this money. Okay, this also can be included depending upon what you have to do on the site, but per cubic meter of concreting work, it doesn't go. This is more on the overall site level. When you have to do the estimation, this cost will also come into play. Okay, so let me give you a little bit more example of the stock calculation. So for a particular construction project, the month-wise stock of basic and bulk material is given below. The contractor's estimated cost of construction of temporary structure is 34 lakhs as we estimated in the previous question here. The month-wise estimated invoice, which is in terms of percentage of contract value, is also given. So this stock that we calculated just now, it's essentially for the total project. So if you want to distribute it monthly, you need to have some estimation of how much quantity of work you will have in each month, and correspondingly you will divide the work, right? So the total stock in this case, all the material stocks, which are cement, coarse aggregate, fine aggregate, reinforcement, plywood, all these values are already given to you in lakh rupees. This should not be bold, this is normal numbers. So 1 lakh, 2 lakh, 5 lakh rupees and so on and so forth. And this 34 lakhs, the total that you have estimated of the other office equipment and the normal equipment, that you distribute according to the invoice percentage, so that you have a monthly breakdown of what is the average stock on that particular thing, because that is common for all the facility. So how do you distribute it on a monthly basis? According to the invoice percentage, right? So the total stock calculation is simple. Invoice is given to you percentage. 34 lakh is the total, that overhead stock that you have calculated. So that 34 multiplied by 2%. So this comes out to be all these values. Then you have cement stock, coarse aggregate, fine aggregate, reinforcement, plywood, timber. All these values are given to you. So the stock of basic and bulk materials, which is just the material side of it, is just B to G. So that is all this amount. The total stock is this value plus the stock of the temporary structure, right? So there's a material stock, which is actual stock, which is easy to relate to. But since accounting refers to stock also as an asset, as a stock, that becomes part of it here. So the cumulative stock is this kind of a monthly basis you can estimate. This is a slightly different example. Earlier the example was 16 months and the total project was 20 months. It's not the same example. Okay. So the average monthly stock you can calculate is average of essentially this series, which will come out to be 18.9 lakhs. So on an average, you need to have this much money stored in the stock kind of a thing in order to execute the project. Why do you need this estimation? Do you know the concept of working capital? What is working capital? So essentially your working capital is what happens in construction. You are incurring cost on a daily basis, right? Because if you are constructing, you are consuming materials, you are consuming the labors. You as a contractor need to pay the labors perhaps daily, maybe much more frequently, compared to what you are getting from the client. Client does not pay you every day. Client does not pay you, okay, today you did so much work, let's pay you the money. But labors you might have to pay every day. Or you're buying all these raw materials, you might need to pay for every 10 days or every week, right? They do not wait for a monthly cycle. So this gap between your income versus your costing keeps on increasing to a certain extent in the beginning of the project. And that is called working capital. Finally, this cost will be recovered. It is not an extra cost to you, but during the project, you need this much money to ensure the smooth operations of your business, right? So working capital is essentially the capital which is stuck in your cycle of production. Cycle of a production is you are buying raw materials, you are doing the construction activity, whatever is value add. Based on that, client is monitoring it, and then finally they are paying you. So the time difference between these two things happening, you need money to still require to fuel this whole cycle. This is called working capital. And that is why this condition, most of the contracts you will see have this condition that for a particular project size, the client financial health is also seen, right? That's a criteria. If you are doing 1,000 crore projects, you can't give it to a company whose annual turnover was 1 crore rupees, because you will easily expect that for 1,000 crore project, 250 crores or something like that could be the working capital requirement. Now a company with total turnover of 1 crore, how will they raise the money of 250 crores to get a working capital, right? So therefore this criteria of financial health that a company can actually meet, temporarily you need to support that much money, right? And if the project is really big, the time value of money kicks in there also. Because if you borrow 250 crore rupees today from the market for 5 years, it is a huge interest that you need to finally consider, and there's a risk associated with it also. So this is where this concept of working capital comes into the hand, becomes important. And this stock is also part of a working capital. This much you need to stock at site. This is not giving you immediate value. Client is not going to pay for them immediately. So this is right now stuck in your system. Finally, all of it will be consumed. At the end of the project, you will have a zero stock. But right now you need to store this, so you need to pay for this, and therefore it is part of your one component of your working capital. Right? That's an important concept. We will devote more time to this towards the later, last few lectures. But right now I'm just giving an example of what working capital, and it is extremely important. Finally, it is recovered. Still the same cost will be charged, and finally client will pay all the things. But in between, you need to have that stock with you so that you can actually pay your all the other suppliers or human resources that you are employing. Right? All right. So this is where we will start from tomorrow. We can stop today. I'll see you tomorrow.